Hello everyone, I'm Eric and welcome to my computational science video series. Today we're going to be looking at C++ and just some of the basics of variables, types, and printing things out to the screen. Now in my last video, this wasn't really the main part of the video, but we had used a statement called cout, and the correct way to use it is actually to put in std : cout, and then we do less than, and then in double quotes we put the phrase we want printed. Alright, now once we've put that phrase in there, if we want to return a new line, we can do std endl. Alright, at the end of every line in C++, we always want to end with a semicolon. Usually we just put it right at the end there. Now in the C++ language, sometimes you'll see this using namespace std. We don't technically need that unless we want to make our code kind of simplified. So we can have this as our program, int main std cout. Now when we build it, it's going to just print this to the screen. Now it might take it just a moment to build because of my IDE that I'm using, but what's happening here is we have a main program. The std is actually a namespace, and it says, okay, we want to use a function called cout that is in the namespace of std. Now at the very start of my file, you see this #include iostream. Now iostream is a collection of functions and objects and things for us to use as programmers, and there's a namespace in there. There might be multiple, I don't know, I haven't actually looked at that file, but I do know that there is a namespace called std, and in that namespace is a function called cout. There's also a function called endl, and with these objects that are in the iostream, we're able to print things to the screen in an easy way. And you can see in the output at the bottom that we have everything printed that we want. So that's how the namespaces work. If we don't want to use and type that std namespace, because we're going to be doing a lot with that namespace, we can use this phrase using namespace std. Then we can make this go away, and if we take the std : away, we can run our program and it'll run again. We've changed our program, by adding the using namespace std. We don't need the std : before those commands that are in the std namespace. So that's really what we're doing, is with the double colon, we're resolving a namespace. But we don't need to resolve the namespace if we declare this statement at the top. What we primarily want to do is we want to look at some variables. Now, in computational science, we deal with numbers. The two main kinds of numbers are integers. So we have an integer I. We might do I equals 0. And j equals 1. We can quickly create integers that way. We could say double, and a double is a double precision number. We could say x equals 0.1. But if we don't want to keep putting variables on a new line, we can use a comma to separate them, and we can say y equals 0.2. So we can create these new numbers, int I and j, and double x and y. And you can see that for I and j, they were on different lines, and that's okay. And x and y are on the same line, and that's also okay. Now if we want to go to some more complex data types, so we have this standard template library that we use to bring in new functionality. The iostream is part of the standard template library. We also have something called complex, and complex allows us to do complex arithmetic. So we can actually create a complex number. For a complex number, we can say complex. Now we have to say what kind of complex. We could say a complex integer, or we could say a complex double, or we could do a complex float. Those are all different types of numbers in C++. Now when I'm using floating point numbers, I do usually use a double, unless I have a very specific reason to go backwards to a float. And I use, just regular integers. So any type of number we can actually put for a type of complex. So the way it works is we'll say complex double, and you can see I'm putting it kind of in between this less than and the greater than. So we're going to say complex double. That means it's a complex of type double. So we're going to have two doubles in our complex. Now we need to give our complex a name. I'm going to call it C. And instead of saying equals something, we're going to put parentheses here, and we're going to define it with two numbers. And I'm just going to say 1 and 5. So we have a complex number c that is equal to 1 plus 5i. So it's like we're saying c equals 1 plus 5i. And this is our imaginary or our complex number. At this point, I also want to talk about another feature of how we can create variables in C++. I really like this technique. This only works in C++ 11, but we can say auto d is equal to complex double, and then after the double we're going to put our parentheses and we're going to say 6 minus 1. And then what we're doing here is we're creating another complex and we're saying that d is equal to 6 minus 1i, or really 6 minus I. So here we're able to create two different complex numbers in a very similar way. I do like that auto notation. By using auto, our numbers look a lot more like they do in Python when we're defining variables. Also, in some situations, we don't have to worry so much about the type. With the auto d, we know that our variable will be initialized, and we also know if we change types in our program, everything will be updated for d. So at the top, we needed a new include to tell it we're using a different set of the standard library, and then we used it. Now, the nice thing about cout is most of the things in the standard library have a way to be seen to the screen. So I can just say cout x equals, and then I'm going to say x, and this is just going to print x equals. I'm going to put a space here, but we can also print out something like c equals c. I'm going to put the endl at the end, and when we run this, we're going to print our double number and c. Or we can make it a little more complex. Let's do some arithmetic. Let's do c times d plus x. All right, we haven't used y yet, so I'll use y. So I'll put that in there. We'll do c times d plus y. And this is going to all be done through the complex arithmetic. So we're going to build our program, and it's going to print to the screen. It's going to say x equals. It's going to put the spaces in. We're going to have an x. Then we're going to have a comma here because of what we have in the string. And we're going to compute c times d plus y, which we have here. And this computation will be done. And whatever the results are of that computation are going to be printed to the screen. So we can see if we do c times d plus y, we get 11.229. All right, so our complex arithmetic is working, and that should make us happy. Now if we want to look at the types of variables and get a little bit more information on that, we can use another include. This is going to be type info. And with the type info, that's going to give us some access to display information about the types. The type of x, and what we can do is we can now say type ID of x, and we need to access the name, because the name is the printable thing that we can put to the screen. All right, so we can get our type ID of x. We can also do things, you'll remember with the complex variables, I defined c and d slightly different. So we might want to check that c and d are the same. So I could say if type ID c, I'm going to see if types of c and d have the same name. So I have to do type ID d. So if the names are the same, then I'm going to see out c and d are the same type. Alright, so here I just have a quick little if statement. We'll learn more about if statements later, but if the type for C has the same name as the type for D, they're going to be printed to the screen. If you looked at the types for those, they're actually kind of complex. Now, I will admit, when you're doing these kind of things in Python, displaying types and things to the screen, I think is a little bit easier. But in C++, I really don't think this is too difficult, and it is far more kind of structured. All right, yeah, so if we look at this, the type of x is D. Now, the reason D is being printed is because x is of type double. If we wanted to do the same thing for I, we could put an I here, and an I here, we would get the integer. And we could do the same thing for C, and you'll see the really long complex name for C. And then we also saw that because C and D are the same type, this was printed to the screen. If they weren't the same, then this would have just been skipped and the program would have exited. But you can see here the type for C is this NST3 blah blah blah. That's a really complicated thing. In fact, if I were to change that D to a float, I think we might get errors and things might go wrong. All right, so that is how types, variables, and print statements work, just kind of in a very general sense in C++. And that's it for today, so keep on coding.